Before we talk about today's new thing, the array list, let's take a little look back at linked lists and understand exactly what they were, because we're going to be building a parallel structure. So after a bunch of work, we spent a couple lectures just building up all these cool ideas, and in the end we came up with this doubly linked structure. We have a size field, a sentinel node, a circular topology. It's all very cool. And what it does for us is it allows us to insert, get, delete items at the front or the back with just blazing speed. Okay? And it turns out the code's not so bad as long as you do it right. And so Project 1A will get you a chance to try that out. Okay, so while it's very fast at these operations, I want you to think about this question. Let's suppose we wanted to write an operation get int I, which you will have to do in Project 1A. Is that going to be fast or slow compared to, let's say, get back? Okay? So just imagine the process. How do you get the back? Follow the pointers, whatever that means, and then think about what it'd be like to get an arbitrary item from the middle of the list. Will that be fast or slow? Okay. Well, it's slow, right? As you can probably, hopefully see, because we have to scan to the desired position. Suppose we have a list that's 1 million items long, and we want item number 500,000. We're going to have to scan through the whole list. So how do we fix this? Well, it's actually a really deep question, turns out. So later in class, we'll talk about some very sophisticated changes we can do to mix up this list and make it fast. But for now, what we're going to do is take a totally different tack and talk about an entirely different backing data structure that will make our list data structure quickly. Okay? So we're still going to want to support these operations, but now we're going to use arrays instead.